Hi everyone, I'm BARACHELLE and I'll be walking you through the introduction and the meter dashboard for Island 67 EV. Our team's co-design philosophy revolves around a dual display concept to prevent a cognitive overload for the driver. We split the interface into two distinct zones. First is the meter dashboard, which is positioned directly the driver's line of sight. It handles strictly driving critical information. Second, the center dashboard, which houses secondary functions like media, navigation, and climate control. By separating these, we ensure the driver is never distracted by non-essential data while moving. Let's take a look at how this works in practice on the meter dashboard. First, we'll notice a speed arc gauge. Instead of a traditional cutter dial, we use a clean sweeping arc that expands dynamically. It gives an instant, intuitive sense of acceleration. Next are the warnings indicators. Right now, they are in the dim state. They blend into the background so they don't distract the driver. But if an issue arises, they transition to high contrast active state to immediately draw attention. When I turn signals and hazard lights, you see these bright amber chevron blinking asynchronously at the top. They are placed intentionally high up to stay the driver's peripheral vision. Finally, down here is the gear indicator. This is designed as a crisp read-only label. Because changing gear is a physical action via a mechanical stalk, the screen simply reflects the current state, P, R, and D, without needing any touch interaction. Everything you see here is deeply rooted in two core HCI principles. The first is glanceability. Driving requires split-second decision. The speed arc, the active warning states, and the amber turn signals are all designed to be processed and understood within a fraction of a second, ensuring the driver's eyes get back to the road immediately. The second is visibility of a system status. The current gear, the critical warning, and the indicators are persistent. They are hard-coded into the layout and remain continuously visible. The driver never has to dig through menus or navigate sub-pages just to know if the high beams are on or what gear they are in. Thank you, and now I will hand it over to discuss the center dashboard.
Hello, I am Evan and I will be demonstrating the middle dashboard which serves as the main touchscreen interface for Elon 6 setup. Before looking at the home screen, I like to briefly explain the persistent interface element that remain visible across all screens. At the top is the persistent top bar displaying the current time and date, the notification center that we call it dynamic Elon, and the switch display button, dark or light mode, back and home button. The notification center serves as important alerts such as incoming call, rain mode activation, and vehicle warning, without interrupting driving, and also music related notification. For example, if I click the notification center, it will show the music related information. Next is the sleep mode. The eye icon. Tapping the sleep mode will turn off the screen to reduce distraction and save battery, where it is useful when parking or resting. Tap anywhere to wake it instantly. On bright and bonnier days, this also helps manage glare. We also have a light mode toggle. Switching to light mode makes the screen bright with dark text, much easier to read under direct sunlight. On the far right is the quick control panel, which contains brightness and volume slider. Because Malaysia use right hand drive, the driver sit on the right. The left hand naturally rests near the center screen. By putting this frequently used control on the far right edge, the driver left thumb reach them without stretching or looking away. This directly applies speed law. Screen edge act as infinite target, so the driver doesn't need to aim precisely. A quick swipe along the edge adjusts volume or brightness in split second. This home screen is on simple view. The left panel displays key vehicle information, including speed, battery percentage, remaining range, and drive mode. The right panel provides quick access such as weather information, music playback, temperature, and fan speed adjustment. Wi-Fi and Bluetooth toggle, call dialer apps drawer, setting and unlock or lock car button also available on the right panel. The purpose of this layout is to present essential information while maintaining a clean and uncluttered interface during normal driving. Cognitive load is reduced and only essential information grouped clearly with no clutter. Now, switching to detail view, the dashboard is organized into three persistent panels. The left panel always shows key vehicle information, same with the simple view. The middle panel contains the same element on the simple view, quick access, and the right panel is context dependent. When navigation is not active, it shows a live location preview, but when a route is set, change to a simplified direction widget such as next turn, street name, and estimated time arrival without switching to a full map. Two principles of HCI are demonstrated here. First, cognitive load reduction, as information is prioritized and grouped into a simplified default layout. Second, visibility of system status, because critical information such as speed, battery percentage, range, and drive mode remain visible across both layout states. This gives flexibility for drivers to switch displays such as someone who wants to preview the map during normal driving can switch to detail view manually, while someone who prefer minimal information stay in simple view. I will now pass to Faris who will demonstrate the navigation and charging station screen.
Hi, my name is Mohammed Faris bin Hussain. So my part is about navigation and charging stations. So let me show you how it works. So for starting navigation, so let's say the driver wants to go somewhere. First, they tap the map icon on the dashboard, and then they can choose a suggested place or type in a destination using the search bar. So once they find it, uh, they tap the start navigation here and navigation begins. So when navigation starts, the layout change, the map gets bigger and you can see turn by turn directions, a progress bar, and nearby places along the route. So everything the driver needs is on one screen. So this follows the principle of visibility of system status, so the instructions and live locations stay visible the whole time, so the driver always knows what's happening. So next part is about battery warning. So the system also has a battery warning feature. So before the route starts, it automatically checks if the battery is enough to reach the destination. If not, a red warning will appear to alert the driver, so this way the driver can plan a charging stop early before it becomes a problem on the road. Okay, so for the next part is finding the charging stations. So let's say the driver sees the warning and needs to charge. So they can tap the car icon on the left side of the dashboard, then tap the stations icon, and a list of nearby charging stations shows up right away. So each station shows how many free slots are available. For example, 2 free means there are 2 charging slots that nobody is using right now. So the driver can go straight in. If it shows 0 free, that means all slots are currently occupied. So the driver knows to avoid that station and pick another one. So the stations are also pinned on the map, so the driver can see exactly where each one is and choose the most convenient route. So this follows the recognition rather than recall. All the information the driver needs is already shown on the screen, so they don't have to remember or guess anything. So for the summary, so navigation takes 3 steps. The system warns you about low battery before you start, and finding a charging station is fast and visual. So everything is designed to keep things simple for the driver. That's all from me. Thank you.
So hello, my name is DYRIL. I will present for the climate control, weather, music, and the setting of Island 6-7 Smart EV dashboard. So first, I will demonstrate the climate control. In climate control, it allows user to adjust the temperature, fan speed, and the airflow, and also the mode. So we design the temperature control using a large plus and minus button, while the fan speed option are clearly displayed and easy to access. So this design apply Fitts law, which state that larger and easier to search target, which require less effort to select. So in a driving environment, this helps user interact with the system accurately without spending excessive time looking away from the road. So this improves the safety and usability. So next is the remote feature. So remote is designed specifically for Sarawak driving condition, where heavy rainfall is common. When rain is detected, so the system display an automatic notification and activate windscreen airflow control to improve the visibility. So next is the weather screen. The weather screen provides current driving condition like speed adjust safely alert, and then hourly weather forecast. So driver can quickly check the weather condition that may affect their journey, such as heavy rain. So this design with clear visual hierarchy, allowing user to understand the critical information and guidelines. This support HCI principle of guidelines ability, which was particularly important in automotive interface. So next is our music panel. This is our user panel looks like, and the last is the setting. So in the setting contains the Wi-Fi, Bluetooth, and notification preference. So rather than display every available setting on the main dashboard, advanced options are grouped within dedicated menus. So this design applies the principle of progressive declosure, where only essential control are shown initially while advanced settings are reviewed when required. So this helps keep the interface reduce cognitive load and allow user to focus on their driving. So that's all for me. Thank you.
Hi everyone, my name is Vince, and for our final section of the demo, we will be walking you through the physical vehicle control, especially for the car detect and tires module, as well with our communication dialer. Let's start with the car detect interface. This is where the driver monitors the physical state of the Island 6-7. On the screen, you can see our immediate control for the door locks, which update instantly when toggled. I would like to also demonstrate our charging system. So when the vehicle is plugged in, the UI smoothly transition from idle to charging, where we included a dynamic charging animation to give the user immediate visual feedback that power is flowing. The driver can also safely halt the session using the stop state control directly from this panel. Moving down to the trunk release, I want to highlight a critical HCI principle we applied here, which is error prevention. Opening the trunk requires a deliberate 2-second hold gesture rather than a simple tap. This constraint was engineered specially to prevent accidental activation, where it ensuring a driver cannot mistakenly pop the trunk open while quickly tapping through menus at a highway speed. Next, we have the car tire status screen. For this layout, we lean heavily into the HCI principle of recognition rather than recall, where instead of forcing the driver to read and correctly process raw PSI numbers, we use intuitive color-coded indicators where the dot map to each wheel and shift from green to yellow and to red. If the pressure drops, a high visibility warning pills immediately appears. This ensures the driver instantly recognizes a critical tire issue in their peripheral vision without having to interpret the exact PSI values. Finally, let's look at the dial pad. For the combination interface in the prototype, we focus purely on the core dialer input. You will notice the keypad features a highly contrast oversized button. By maximizing the touch target size, we drastically reduce the motor control position required to use it, where this application of Fitts law allows the driver to punch in the number confidently with minimal visual distraction. That's cover our project group prototype demonstration. So to briefly summarize our work for milestone 5, we have successfully translated our high-fidelity design into a robust interactive web application, whereby utilizing front-end state management and our interface deliver immediate context-aware visual feedback across all primary safety matrices. Thank you.